In this video, we work on the marketing research problem found in Chapter 3 of the textbook. This problem is important for us because it shows how the criteria can change based on the solution that solver comes up with. So let's take a look at this. We have page 75, a description of what we're looking for. It's a polling company, political polling company, and there are 6 criteria here laid out. The company is to survey at least 2,300 people in the United States, survey at least 1,000 people who are 30 years of age or younger, survey at least 600 people who are between 31 and 50 years of age, ensure that at least 15% of those surveyed live in a state that borders Mexico, and ensure that at least 50% of those surveyed who are 30 years of age or younger live in a state that does not border Mexico, and ensure that no more than 20% of those surveyed who are 51 years of age or over live in a state that borders Mexico. So the first question is, what are we making? We're conducting a survey. We're surveying people, and we have 2 criteria for our people. There's an age criteria, and there is a residency criteria. We have 3 age groups, and those 3 age groups we have to distinguish between those living in states that border Mexico and those not living in states that border Mexico. So we're going to make 6 things. We're going to get people who are less than or equal to 30 in age and they border Mexico. We'll get people between 31 and 55 and border Mexico. So we'll get all our age groups together here. Then we'll get those greater than or over 51 and border Mexico. Then we'll get those less than or equal to 30 and not border Mexico. We'll get those between 31 and 55 and not border. And then we'll get those greater than or equal to 51 and not border. Now let's go ahead and set up our solution row. It'll tell us how many of each we're going to do. And let's go ahead and set that row to yellow just so we can kind of get a visual idea of how our model is laying out. I always use yellow to indicate the solution row. That helps us kind of orient the model. Now we are provided with a table and some costs for surveying these people. You might have struggled with coming up with these. How do you come up with these? Well, you get a lot of clues, but one of the clues is in this table, a very big clue. The costs, the way they're broken down, define the type of person that we have to interview. In other words, because we have a cost for participants less than or equal to 30 in age and living in a state bordering Mexico, we're going to need to have them identified in our model. So as you look at this table at the bottom of the page, you can see there are 6 breakdowns, 6 costs. So that serves to define our 6 titles. So you can do it that way as well. Sometimes the data, the way it's presented, helps you if you're going to maximize profit or if you're going to minimize costs. You're going to be provided with cost and profit data, and that helps define your model. So let's do this. Here is the cost. So this will be a cost minimization problem. We're provided with the costs here, $750 for those bordering, $680 550. And then not bordering states, we have 690, 7 1/4, and $610 per person to interview. I'll just balance that out. Now let's put in our constraints. To do that, it might be easier if I identify a couple of more fields in the model. I'll go ahead and put in our solution set that we'll find later. Make that green. And then under that will be the criteria. We'll have our greater than or equal to signs here that just serve as reminders, and then we'll have the actual criteria value themselves. So the first criteria, it says in the list, survey at least 2,300 people in total in the United States. So we're going to put in a counter here, total households, and we're going to count every time we survey a household. Any household we survey is going to be added up here, and it's going to be greater than or equal to because it says at least, and that was 2,300. I'm going to go ahead and center these values here so they're a little easier for you to see the columns to which they belong. The next criteria says survey at least 1,000 people who are 30 years of age or younger. So here we go, less than or equal to 30 households. We want those households. So every time we conduct a survey, whether it's in a border state or a non-border state, in a household that is 30 years of age or younger, we're going to count them toward this 1,000 constraint. Then survey at least 600 people who are between 31 and 51 years of age. So we have 31 to 51 households. So we'll go over, and every time we survey a household where the residents are between 31 and 51, we will count them, and that's 600. The next criteria, ensure that at least 15% of those surveyed live in a state that borders Mexico. All right, so border Mexico. Now we have a criteria that depends on an outcome. They didn't give us a set figure. They didn't say ensure that at least 500 are that. They want to make sure that 15% of all of those surveyed live in a state that borders Mexico. So there are two ways to do that. First of all, we need to turn this on. These are the surveys that will be conducted among people of any age group who live in states bordering Mexico. These are the border Mexico columns. Now we want to go over, and I can just continue this greater than or equal to now because they're all at least, aren't they? This value needs to contain the total number of surveys at any given time in our model. There are two places where that information can be found. First, this cell will always track how many surveys are being conducted because this is our counter. Also, these cells, when added together, will show the total number of surveys being taken. The book uses these. We have a counter, we could use these as well, but I'll stick with the book. We want 15% of that total. So this constraint is going to equal 0.15 times the sum of all the surveys the model decides to take. In any iteration of the model as it's calculating our optimal value, we'll have the correct constraint here using that formula. The next constraint says, ensure that at least 50% of those surveyed who are 30 years of age or younger live in a state that does not border Mexico. So we have another similar constraint, we have less than or equal to participants and not border. So here is our less than or equal to and not border value, and we want that to be 50% of those. So it's going to be greater than or equal to, it's at least, and we're going to take 50%, 0.5, and we're going to multiply it times the values that we get up here in our solution row for the less than or equal to participants. We'll need to, because of order of operations, we'll need to put this in parentheses. So here is a less than or equal to solution. So we'll add that to another less than or equal to 30 solution. And this will keep track of all of the participants who are less than or equal to 30 years of age, and it will make sure that half of them are not bordering, greater than or equal to half. The final one says, ensure that no more than 20% of those surveyed who are 51 years of age or over live in a state that borders Mexico. Now this is a no more than, so we can go ahead and put this. This will be less than or equal to, and the criteria involves those over 51 years of age, and we want to ensure that they border, so no more than 20% live in a state that borders Mexico. So here is the counter for those who are greater than or equal to 51 and border Mexico. So count every time I conduct one of those against this criteria. Then we'll go and create the criteria. It's going to be 20% times, and then for sake of the order of operations, we need to use parentheses. We're going to go up here and get the cell where we're going to count the number greater than or equal to 51 and border, and we're going to add to that the cell where we count those greater than or equal to 51 and not border. And that's going to give us all of the greater than or equal to 51 year of age households in our survey, and we're going to make sure that 20% of those or less live in a state that borders Mexico. All right, so now we have our criteria set up. Let's go ahead and do our sum products. The solution set, absolute, comma, the row to my left. All right, we'll do these, equals sum product, the solution set, absolute, comma, the row to my left. And we'll copy these down. We'll make these light blue because they're calculated, and I'm also going to make these light blue just to show you that they are calculated as well. Now, I'll place my cursor in our objective cell. I'll go to Data, select Solver. Here's the objective. H6, that's correct. It's a cost minimization problem. We're going to minimize cost by changing the yellow cells. We have some constraints which we will add. Move my constraints over here so it's clear to see the signs. we have some greater than or equal to constraints. We have some less than or equal to constraints. I'm going to do them out of order just to show you that it doesn't matter what order you put them in. I'll do the less than or equal to constraint first. Here's the cell reference for that constraint. Here is the constraint itself. I have more to add, so I'll select Add. Here are the cell references for the greater than or equal to constraints. I'll change the sign to greater than or equal to. Here are the constraints themselves. Some of them are yet to be calculated. Okay. Again, I'll ensure that the unconstrained variable non-negative cell is checked and that we're using the simplex LP model. I will select Solve. Move that over here. You can see the solution is here. I'll accept the solution. Okay. And now I can take a look at the model. I'm going to survey 600 of this type of respondent, 140 here, 1,000 here, 560 here. I'm not going to survey any of these. This creates the criteria. This would satisfy the 15% of all criteria. This satisfies the 50% of those who are less than or equal to 30 years of age and do not live in a border state. And this satisfies the criteria that no more than 20% of those over 51 surveyed live in a border state. So this is how you construct and solve a linear programming model when the constraints are defined as the model is completed. Notice here the binding constraints, where there is no slack, and notice the non-binding constraints, these two, where there is slack, difference between the constraint and the output, the outcome, and then again a binding constraint here. That's how you do it.